This Week in Virology, the podcast about viruses, the kind that make you sick. From Microbe TV, this is TWiV, This Week in Virology, episode number 375, recorded on February 5th, 2016. Hi, everybody. I'm Vincent Racaniello, and you are listening to the podcast all about viruses. Joining me today from Western Massachusetts, Alan Dove.
Good to be here.
Have you got snow today?
We did. We got about 4 inches out of this.
Yeah.
Took me a whole 25 minutes to shovel off my driveway this time. Really wet snow.
According to my forecast, we were supposed to get 13 centimeters. Actually, there's still more snow forecast here, but we got 4 inches. It was very thick and heavy. The branches were breaking. The electrical wires were sagging. Oh, well. Also joining us from southeastern Michigan, Kathy Spindler.
Hi, everybody. It's gorgeous here. 36 degrees, feels like 30. That's in Fahrenheit. In Celsius, another thing says it's 2. Bright and sunny, and we don't have snow in the forecast until Sunday, but it's going to be 43 degrees, so probably won't stick.
Cool.
Also joining us from north central Florida, Rich Condit.
Howdy, everybody. It's 58 degrees, 14 Celsius, clear blue skies. There's no snow in the forecast for the next about 1,000 years. And it's all good. I'll step aside here. We got a full boat. I'm going to sit here in the bilge and listen.
Yeah, listen to him with the sailing metaphors, right? Yes, we do have 3 guests. Well, Dixon will be around in an hour. He'll come crashing in, making noise and hitting the mic and yelling. But we have an hour of solitude and peace.
Hey, be nice to Dixon.
He's not here.
Be nice to Dixon.
We have 3 guests. One of them is back because she loves TWiV. You may remember from the University of Pittsburgh, Carolyn Coyne. Welcome back.
Thanks for having me again.
This is like 4 or 5, right?
I don't know. No. I think it's only 3, maybe 3. Yeah.
And it's amazing you're back. And after my trip where I got stuck in the snow and I asked you back on TWiV, how about that? Obviously, I didn't blame it on you.
You weren't too angry at me. Yeah.
We also have a newcomer to TWiV. She is, North Carolina, UNC Chapel Hill. Helen Lazear, welcome to TWiV.
Hello. I'm actually not a TWiV newcomer. I was on episode 193 live at ASV in Madison.
That's the one I did with postdoc.
It was. I was a postdoc then.
I'm so sorry. I forgot.
What are you
My affiliation has changed, though, so I'm now at the University of North Carolina.
Holy crap. At the time, where were you? You were with Michael Diamond, right?
Yeah, I was a postdoc in Mike Diamond's lab at WashU.
I thought you looked familiar. But this is the problem with getting old.
You don't even know where your phone is.
I don't know where a lot of things are. That was a great episode. Oh, good for you. And I know at least one other person, Kara Podger, has a job up in upstate New York. You know about anybody else from that episode?
I believe Matt Doherty is starting a lab in San Diego.
Wonderful. He's been with Harmit Malik, right?
That's right.
Yeah, he contacts us a lot. Oh, cool. And I did that episode because I had done a one with postdocs in Glasgow, and everyone was depressed, and we were on their 4th postdoc and weren't going to get jobs. I said, this can't be the case all around the world. So I did one with American postdoc, North American postdocs, and it was very uplifting. How long have you been at UNC?
Just a few months. I started in November.
Good for you. Congratulations.
It's been an exciting time to get started.
Yeah. All right. You're second on TWiV. Probably there'll be more, I would guess.
I hope.
Because you're a young person and you understand this social media stuff, right?
I guess I try.
Yeah. Okay.
Well, I talked to Helen a few months ago for a story that I was working on. I didn't know that she'd been on TWiV either. I just came across her as a source for the story.
Yeah. I mean, she has written a couple of times, and the name has always looked familiar, and that's probably why. Hey, we have 375 episodes, I can't keep track of them all.
TWiV's just bringing everybody together.
Yeah, well, now I'll remember you. All right, we have one more guest here in the studio. He just showed up this week.
Also a repeat offender.
He's been here before. In fact, he was on TWiV way at the beginning. And he's here for business, and he's here for like the whole week. I said, come by and if you're free at 2 p.m. on Friday. Jeremy Luban, welcome back.
Hello, everybody.
Now, last time you were here, I think the last time you were on TWiV, you were in Switzerland. Or no, maybe not. Colombia.
There was... yes.
There was one
I think I was in Switzerland. There were 2 in Switzerland, I think. Maybe 3, actually. There was one where I was in your office here. In the TWiV studio here. When we talked about Trim 5 and some other things.
And also we did one on Ralph
Steinman. That was the same episode.
So it looks like TWiV 11, TWiV 16, and TWiV 157.
That would be 157, yeah.
11. You were at episode 11. Amazing. That's a long time ago.
Yeah. Well, I was having lunch here before TWiV was established.
Yeah, that's right. You used to be here. You went to Switzerland, and now you're at UMass Worcester.
That's right.
Excellent.
You're not too far from Allen.
That's right.
Yeah.
I think our weather's probably at least as bad as his. There was a snow day today. I hear. I'm not there.
Really? Your kids didn't go to school?
That is correct.
Wow.
Though we live a little further east. But,
we had a snow day here. They were total wimps about it. The superintendent called at like 5:30 in the morning, and I looked out the window, and it wasn't even sticking to the roads yet.
Yeah. No,
they just gave up.
That's what happened by us. But, when the weather's bad up there, I look in Verkhoyansk, where right now it's minus 63 Fahrenheit, which is about minus 53 centigrade. So that always makes me feel, well, sometimes it's awfully close to the temperature in Worcester. But
somebody suggested last winter when it was really, really horrible, they said, you can cheer yourself up sometimes by looking at the weather in Yakutsk. And I looked it up, and it was actually like a couple of degrees warmer there. I said, no, this is not helping.
Excellent. Well, Jeremy is an MD, right? You're an MD, PhD.
Just MD.
You're not a PhD? Okay.
No.
So you're just an MD.
I just torture PhDs.
You've had some clinical experience.
Like Alan Dove. I was on his defense committee. Yeah.
Wow. Yes.
This is insider baseball here. And so I thought you could chime in. People often write in and say, you need to get a doctor on the program. So here you are. If we say wrong things like what pruritus is, you can correct us.
I'll just scratch behind the ears.
This episode of TWiV is sponsored by a very short meeting, the 32nd Clinical Virology Symposium. Abstract submission is now open for this meeting. It's taking place from May 19th through the 22nd in Daytona Beach, Florida. You have until March 17th to submit your abstract, which could be on rapid viral diagnosis, the clinical course of viral infections, and how to prevent and treat virus infections. There'll be over 1,000 people there, researchers and primary care physicians, which Jeremy, we know, is not. He's not a primary care physician. He may be a doc, but doesn't do that.
That's right.
This is an ASM meeting. It's actually 32nd is the number 32nd, 32ND, because it's been going on for 32 years. It's not a 32nd meeting. It's not really short. But I'll bet there'll be some Zika abstracts submitted by March 17th. So if you want to find out more about this meeting and register, go to asm.org/CVS2016. So this is Zika. This episode is all about Zika. I had some follow-up. I took it out because we're going to go right into Zika because we have a lot to say. And we have Helen here because you are a flavivirologist, right?
That's right, and rapidly becoming a Zika virologist.
Which flavivirus did you work on in Mike Diamond's lab?
So most of my postdoctoral work in the Diamond Lab focused on West Nile virus and the innate immune mechanisms that control West Nile virus pathogenesis. But I actually started working on Zika virus while I was in that lab. Huh. So I hope I can say I was working on Zika before it was cool.
Before it was cool, yes.
So
what led you to work on it?
Yeah.
Well, Zika was one of a couple of different flaviviruses that I had on my radar as being viruses that seemed like prime candidates for wider emergence. And Zika virus, that was because of a sort of the outbreak that had been ongoing in the South Pacific for a few years. And so with that in mind, I started to set up some in vitro assays and a mouse model of pathogenesis with the idea of having some tools at the ready should there be a greater emergence. And here we are. The similar bet on Usuchi virus hasn't quite paid off yet, but you never know.
That's great.
So where did you get your Zika virus?
We were able to get some samples from the Arbovirus Reference Center at UTMB through Bob Tesh, and then other samples through the CDC.
And what sort of safety precautions do you have to take working with that and other flaviviruses?
You can't have sex.
Well, we didn't have that one in our IBC protocol specifically. Zika virus is a BSL-2 virus, so it doesn't require any particular precautions. And that's a little bit unlike some flaviviruses like West Nile virus or Japanese encephalitis virus that you'd use under BSL-3 containment. Now, when I started that work, we didn't know very much about Zika virus. We still don't know much, but we knew even less then. And since then, we've learned more about potential more serious complications of Zika virus infection. And so I think now we have additional safety precautions in place because of that.
This is
Do you know if you're seropositive?
I have not been tested. I would think I wouldn't be because with proper lab safety procedures, there's no reason that you would seroconvert.
Right.
That's right. Okay.
She's going to put you in your place, Condit. And then Dixon. Wait till Dixon gets here and starts spouting off about West Nile. Please put him in his place, okay? Because he thinks he knows everything about it, but you actually work on it. So we have an authentic Zika virologist here. As usual, TWiV leads the way. This is great. This is wonderful. So we have had quite a few emails, which I've saved up and scattered through the show notes. So we'll kind of use those to guide us. And Marcus had written, he said, after last year's success with the TWiVziks episodes, This Week in Ebola Virus, I don't know how successful they were. Actually, he's right. The Ebola episodes are the most viewed, most listened to episodes in our back catalog. And
the outbreak is under control now, so apparently it worked.
They got the TWiV bump. And those episodes are going to be going to vinyl soon. They're so popular. Anyway, Marcus says, I thought you might like to do some similar episodes on the current big virus news in the media, Zika. Other than being interesting, sad, and difficult to handle, TWiZ has a nice ring to it. All right. So we did an episode back in December, right?
Mm-hmm.
Yes.
Which nobody has remembered or paid attention to because now it seems to be exploding more than it did back then. So I like to think we were ahead of the curve, although
Of course we were.
Of course, Helen was ahead of everybody, which is great.
Maybe that episode is just hide and Zika.
Hide and Zika. That's right. So, Helen, can you bring us up to date? So we went through the basic biology and so forth, but bring us up to date. I'm sure you know a lot more than we do.
Sorry, I lost you guys there.
Uh-oh.
Oh, we finished the episode.
Oh, good.
It's all over. I thought you were just being quiet.
It's done.
Yeah. You stopped hearing us?
Yeah, I lost my sound for a sec there.
Okay, that's okay. To bring us up to date on the numbers in Brazil, when did it actually start, and what are we up to now?
Well, anything about numbers is going to be pretty hard to talk about because we don't have great numbers for pretty much anything to do with this Zika virus outbreak. So in terms of total case numbers, in a lot of instances, we're really looking at estimates. You hear an estimate of 1.5 million infections in Brazil. But, it's hard to say, in part because for Zika virus, most people who are infected aren't showing any symptoms. Even if you are showing symptoms of Zika virus infection, they're very nonspecific, a fever and a rash that could be due to a lot of things. And then even if you go for a specific diagnostic, diagnosing Zika virus is difficult because there's serologic cross-reactivity between Zika virus and dengue virus. So the only way to be certain that someone has a Zika virus infection is to test for, to do an RT-PCR test to look for viral genome. But that's only going to work for the initial acute phase of the infection, so not for very long. So it's difficult to have an accurate number on the number of Zika virus infections. We know a little.
Let me ask, because the CDC website also says cross-reactivity between yellow fever virus and dengue virus.
Yeah,
And
that's probably true. Flavivirus diagnostics generally are kind of a mess because between all of the members of this family, there's a lot of cross-reactivity. But of course, the more closely related two viruses there's greater cross-reactivity.
Sure.
And Zika and dengue are quite closely related. So that's really where things get more difficult.
So, Helen, is the cross-reactivity at the just antigen, or is it at the neutralizing antibody level?
Certainly at the antigen level, and then we don't know as much about at the neutralizing level, but probably some there as well.
So it should be possible to make a monoclonal that would be more specific, right?
It is possible and being done.
All right, so basically all of the serology we see, we have to be suspect, especially if there's dengue or yellow fever in the same area, right?
Absolutely. And when we're talking about Latin America and the Caribbean, dengue is highly prevalent. So pretty much everybody is going to have been exposed to dengue virus previously.
Before Brazil, how many total Zika infections do you think there were globally?
I'm not sure. I mean, certainly in the earliest decades after Zika virus was discovered, it caused just sporadic infections that we know about. And then we have documented outbreaks in Micronesia and in French Polynesia starting in 2007 and in the years afterwards, with the virus then being detected in Brazil in 2015. But I'm not sure that we have accurate case counts in those areas either for the same reasons. I mean, dengue is prevalent in those areas as well.
Yeah.
So it was originally discovered in Africa in about 1950. Is that correct?
1947 in Uganda.
And so is it not endemic in Africa?
It's presumably endemic in Africa as well, with probably primates as reservoir hosts. And we would think that the virus circulates there between mosquitoes and primates, with occasional infections in humans as well. And there have been examples of humans infected with Zika virus in Africa historically.
So I went back to the original Yap Island outbreak, which is one of my favorite names.
Yap.
And they did serology. So do you know if there's dengue on Yap Island, Helen?
I believe the area has dengue, yeah.
Okay, so they figured that about 70% of the residents 3 years of age or older were infected with Zika. And the population on the island is over 7,000 people as of 2000. So,
now, I think that count was an estimate based on a smaller number of samples that they ran and then extrapolating from that.
They didn't test every single person?
No, they didn't. They don't. How many do you have to test to get a good estimate, Jeremy?
Woof. You're asking the wrong... I'm an MD, remember.
I'm glad I didn't say that.
The issue, and I think the real issue with Brazil is that you need good numbers locally because the rates are probably very different in different parts of Brazil. The geography and the population and the mosquitoes is probably very different from state to state.
Yeah. Now I just wanted to point one thing out about the Zika in Yap Island. In this paper, which is a New England Journal paper, they were not able to find virus in any mosquito. Do you know anything different about that, Helen, or is that the case?
No, I mean that's my understanding as well, and I think the presumption is still that it was transmitted by mosquitoes, and sometimes you just don't detect virus in mosquito pools. That happens in examples of other outbreaks as well.
But the fact is that in Africa in the earlier days, they did find the virus in mosquitoes, and so.
Absolutely. And so in the original study where they isolated Zika virus from a sentinel monkey in a virus research station in Uganda, they also found the virus in mosquitoes in that same area. And then there have been many examples, in the following decades where people have found Zika virus in mosquito pools.
And so the main mosquitoes are Aedes mosquitoes, right? Mm-hmm. A variety of species of that genus, right? Now,
so Zika virus has been detected in many species of Aedes mosquitoes, and we think that in terms of the human outbreaks, Aedes aegypti is going to be the main driver of that.
I saw on ProMed Mail just a few days ago, there was a nice summary of all the countries in the area and how many cases, including the U.S., and there was a little note here that said, experts at the Oswaldo Cruz Foundation said the virus may have already crossed to Culex species. I don't know what the data are for that. They don't really say it. What is that likely to happen, Helen?
Well, I haven't seen the data for that either, so I guess I can't speak to that specific report, but there certainly are examples where, you can detect a virus in a variety of different mosquitoes, but that doesn't mean that those mosquitoes are important for transmitting that virus in nature. It would have to do a lot with how good they are at transmitting it and their behavior and biology.
So if it's limited to Aedes mosquitoes, is that going to allow extensive spread in the U.S.?
Well, the Aedes aegypti mosquito, that seems to be the main driver of these outbreaks, that is found in parts of the southern United States. And so it's possible that could start a local transmission in the U.S. But I think there's a number of lifestyle differences in the United States that protect us from large outbreaks of mosquito-borne diseases. And so that's things like air conditioning and window screens, vector control, and we have winter on our side here. Yep. And, I think a useful parallel is to think about viruses like dengue virus and chikungunya virus. These viruses are found in all the same areas where Zika virus is emerging, and they're transmitted by the same Aedes vectors. And we do sometimes get examples of local dengue or chikungunya transmission in Texas and in Florida, but so far that's not really taken off in terms of a large-scale epidemic in the U.S. And so most likely those same sorts of factors would prevent a large-scale Zika outbreak as well.
So why was West Nile able to spread it in 99? Before 99, it wasn't here at all, and then it came in 99 and boom, spread across the whole country.
Well, although West Nile virus and Zika virus and dengue virus, these are all flaviviruses, their biology is different. So Zika virus and dengue virus are both examples of flaviviruses that have humans as their amplifying hosts, humans and then also non-human primates. And so that means that humans develop a high enough viremia to reinfect a mosquito. And so you can develop sustained chains of urban transmission between humans and mosquitoes without a need for an animal reservoir. For West Nile virus, the case is different. There, humans and other mammals are dead-end hosts. So humans don't develop a high enough viremia after West Nile virus infection to reinfect a mosquito. Instead, West Nile virus is maintained in an enzootic cycle between birds and mosquitoes, in this case, Culex mosquitoes. And so because of that, and because birds don't have the same lifestyle protections that we do against vector-borne diseases, they're not in air-conditioned buildings all day long. The biology of the viruses is quite different, and that's really important for the ability of those viruses to spread.
Okay, so can you tell us what you know about the introduction of Zika into Brazil, like roughly when and how it got there?
Zika virus was first detected in Brazil in 2015, and so
don't blame the World Cup.
I was not about to. Most likely, it was brought over in 2014 because it takes a while to spread and to come to everyone's attention, especially in an area like Brazil where there's already a lot of dengue. You could imagine it might take a while before you would notice another infection that looks a lot like dengue. We don't know how it was introduced. People toss out the World Cup or a canoeing championship as an example, but first of all, you can't know. And also, it doesn't really matter, and it doesn't have to be a big event like that. You could have just one traveler who brought it over, or one mosquito.
Yeah, somebody shipped a load of used tires.
Exactly.
So there's West Nile, right? Yeah.
I visited Brazil in 2015.
Oh,
it's your fault.
You did it.
So the virus was first detected in Brazil in 2015, and after that it proceeded to spread first throughout Brazil and then throughout the rest of Latin America and the Caribbean. I think we're at 26 countries now that have reported local transmission of the virus, and every reason to think it'll spread throughout the whole region.
Now, do we actually know that it spread in that order, or is that just the order in which we detected it? That it went to Brazil first and then elsewhere?
Yeah, that was the order it was detected in. I guess it would be hard to know if it spread in a different order. I guess you could do extensive sequence comparisons after the fact to reconstruct that.
So the reason it has spread so quickly is because there's no population immunity in this region, right?
I think so. People have talked about how, this is a very rapid spread and it's spreading alarmingly fast. And I suppose that's true because in the space of about a year, the virus has spread throughout the whole region. But the rate at which Zika virus has spread is pretty similar to the rate at which chikungunya virus spread after it was introduced in the Caribbean in 2013. So that probably tells us more about the biology and vector competence of the Aedes mosquitoes that transmit both viruses, as well as what happens in a naive host population, rather than something particular about Zika virus.
And there's also probably the phenomenon of denser data collection. I mean, in the areas in Africa where this virus was originally isolated, it was because they put a monkey in a cage in the jungle. And this is not an area that has a very high reporting rate for a disease that's largely asymptomatic. And then when you get it into an area that's more populous, people start noticing.
So is there anything special going on that's promoting the spread of these viruses into new places? It's just the modern world with more travel and higher population densities?
Yeah, I think so. I think what we're seeing with Zika virus and its spread in the Western Hemisphere is pretty similar to what happened with chikungunya virus when it was introduced a few years ago. And honestly, it's probably not going to be the last example.
Mm-hmm. So, Helen, the fact that a lot of people in these areas have been infected with dengue, couldn't we say that doesn't appear to be inhibiting the spread of the virus infection?
Yeah, I think so. I think it's pretty clear that prior dengue immunity must not prevent subsequent Zika virus infection. What we don't know, and what will be very interesting to determine, is if prior dengue immunity makes Zika disease worse, which is a possibility through antibody-dependent enhancement that happens between different serotypes of dengue virus.
Right, that's what you had written to us after the December Zika episode. And you had suggested that, and you said you were investigating it. In fact,
aren't there issues about the actual mosquito populations changing and the control of those or spread of those that are relevant to this? I mean, that are not steady state, or maybe I'm
not sure about that. I mean, certainly there have been efforts to control the mosquito population in the past, and that clearly hasn't worked in the long term. And so there's probably some amount of change over time, but I'm not sure if there's any connection between that and the spread we see here.
All right. So now a number of the emails get into the microcephaly issue, which is one of the big reasons why this is making the news. Maybe you could summarize what's happened with that, Helen.
I agree that microcephaly is the reason this virus has been getting a lot of attention lately. Of course, it's always very interesting when you have a new pathogen in a new host environment. It's important to learn more about it. But the potential association between Zika virus infection and microcephaly is really what's been driving the attention. And so Zika virus was first detected in Brazil in early 2015. And then by the fall of last year, there started to be a report of an increase in cases of microcephaly. And I believe now we're at about 4,000 some cases reported. And I think we'll talk about this some more. There are a lot of questions about the numbers coming out, and in particular, how accurate the baseline values are, how accurate the current numbers are, and what we can say about an increase. We don't yet know whether Zika virus infection causes microcephaly, but people are working hard to gather a lot of data, in particular documenting Zika virus infection in fetuses and infants with microcephaly, and then trying to get better data about the numbers so we can have a better sense of the size of the problem as well as the risk.
And we should probably define microcephaly at this point.
Good luck.
Well, yeah, exactly. So this is not a condition where, the test came back positive for microcephaly. It just means small head. And if Jeremy, I'm sure, will correct me if I'm screwing this up, but it's based on the circumference of the infant's head at birth, right? Sorry,
I was distracted by Dixon DePalmier. He's got a terrible cough. Yeah, as I understand it, the initial primary criteria is the circumference.
Right. So you pick a cutoff and you say if the head is smaller than this cutoff, then the child is diagnosed as microcephalic, and there's some discussion over the years about where that cutoff should be. But the outcome of this is that it can be a very debilitating condition.
And there's a number of different factors that can cause microcephaly. There are certainly viruses that are known to cause it, also environmental factors, genetic causes as well. So anytime you document all of the cases of microcephaly, especially if you're looking very hard for them, many of them are going to turn out to be due to other causes that we already know about.
Right.
Maybe this is a good time to ask Carolyn. Are you still there?
I'm listening. I'm learning.
I bet you're learning. I'm
taking notes. Yeah.
We're going to get back to the microcephaly thing, but in order for a virus to cause microcephaly, it would have to cross the placenta. Is that correct?
Yeah, in theory. I mean, so the reasons that suggest to me that Zika virus, and which would of course make Zika virus very unique, but that Zika virus is actually crossing the placenta to get into the fetal compartment, is the fact that the babies are being born with something like microcephaly. So if it were instead that Zika virus were just, replicating and infecting the placenta, and you would get, say, direct damage to the placenta, oftentimes how that presents itself is through like an intrauterine growth restriction. So that's just that the babies are smaller sizes, pregnancy doesn't normally go to term, the placentas are smaller sizes, babies are smaller sizes, you often have preterm delivery, often miscarriages. And so at least based upon if Zika is linked to microcephaly, to me it actually would suggest pretty strongly that the virus probably does directly access the fetal compartment to induce the disease.
Does CMV or rubella cross the placenta?
Well, they do. Oh, yeah. I think quite adeptly. Oh, sure. And they're one of the torch pathogens, which we can talk about now or later. But so CMV and rubella, VZV, HSV2. I mean, those are all viruses that are associated with congenital disease and are thought to be transmitted vertically. Although, it's important to note that although we know in those cases that there's a very strong association between infection with a given, outcome in a baby, we still don't understand how those viruses actually get across the placenta, which is not easy.
Yeah, having just visited you, I was impressed at how hard it is to get across the placenta.
Absolutely, yeah.
Those outer cells, what are they, the syncytial trophoblasts?
Yeah, so the placenta, and again, the other thing to keep in mind with the placenta, which is very unique to humans and is something to think about when considering Zika, is that the placenta changes dramatically throughout pregnancy. And so the placenta in the first trimester is actually quite different than the placenta in the second and the third trimester. And I think that's going to be really important when we start tracking when pregnant women perhaps exhibit symptoms with Zika virus, because it will give us some information, I think, about potential mechanisms of crossing the placenta. Mm-hmm. But yeah, getting across the placenta is quite difficult because in the human placenta, which is called a hemochorial placenta, you have an outer layer of cells which are called syncytiotrophoblasts. So those are the syncytialized cells of the placenta, which are, of course, fused through syncytin, the endogenous retrovirus protein. Below that layer is an additional layer of trophoblasts that are called cytotrophoblasts. And those cells are mononuclear, and those are the cells that actually fuse to form the syncytium. But that's not even the only thing that the virus would have to do. So it would have to basically cross both layers of those cells. It would have to enter into what's called the core of the villus tree of the human placenta, which is composed a lot of fibroblasts and some other factors. And then it would also have to cross the fetal microvasculature. So for a virus to start its sort of vertical transmission by directly replicating in let's say the syncytiotrophoblast, it wouldn't just be infecting that cell to get into the fetal compartment. It would actually have to go through several layers of cells in order to reach the fetal compartment.
One does not simply walk into the placenta.
No, evolution does not let that happen.
Are you planning to look at whether this virus can infect syncytiotrophoblasts?
Oh, for sure. I mean, and it's one of the things that I think I will be, quite frankly, shocked if the virus does. So what we do is we culture primary syncytiotrophoblasts from term placentas. And so, we don't know, of course, what could happen with a syncytiotrophoblast layer from, let's say, a first trimester, which is more difficult, of course, to work with. But, what we've found in our work with those primary cells is we've yet to identify a virus or anything really, not even a virus, but anything that will actually replicate actively well in those cells. And so, it's possible that Zika will, and that will give us some insight. I suspect that won't happen, but yeah, absolutely, it's something that we'd like to test.
So when viruses do cross, they're not actually replicating in the syncytial cells.
Nobody knows. So that's, and again, that's kind of what you learn when you start, and hopefully even if nothing else, perhaps good comes of this, people start recognizing, I think, how very shockingly little we know about the human placenta, but also how microbes that do induce congenital disease cross the placenta. I mean, for the torch pathogens, which of course are toxo, now other, which is VZV is included, listeria is an other, rubella, CMV, and HSV, usually HSV2 is associated. We don't know for any of those pathogens the real concrete mechanism of vertical transmission. For CMV, there's been some clues, but for everything else, we know very little.
It's interesting that you say we know so little. In fact, you wouldn't have been interested in it if you hadn't developed one, right?
That is true. Yeah. So, I mean, I'm obviously not a medical doctor or a trained placental biologist. Yeah. How I started working on it was I got pregnant, and this idea of sort of what was protecting the baby from the viruses I work with. And really how it happened was just that, as I came to the computer, I thought, well, for sure someone knows these answers. These seem like these are fundamental to like human biology. And I was really shocked, and I still remain rather shocked at how little we know. So that's really why we started working on it.
So,
I'm back.
Oh, you're back. Sorry, I didn't call you because
Yeah, it's okay.
You got it all worked out.
Yep.
Good.
Well, I guess. Sorry.
See, no, it's no problem. You missed an awful lot of good stuff,
I'm sure I did.
but you'll have to listen. So, maybe Jeremy, you looked a little bit at the incidence of microcephaly. Do you have some thoughts on that?
Well, overall the numbers are quite confusing, and I think there are lots of details about the numbers that make you concerned that we don't really know what the numbers are.
Right.
So to start, the frequencies of reports of microcephaly in Brazil overall and in individual states within Brazil was on the order of 10, maybe more fold lower than it is in the United States and Europe. So that gives you the impression that over the past decade, for example, there was underreporting, unless the rates really are tenfold higher in the Northern Hemisphere. And I think even in the United States, I'm not sure how good the recording of these numbers are. I checked with someone I know at the CDC, and he just wasn't aware about the specific mechanisms for obtaining this data. But in general, as was alluded to earlier, when you look at you try to derive a number for a country or for a large region, you usually take samples, and the data is only as good as the samples you take. It's possible that there is a system in the United States that is more complete, but I would actually be surprised if that were the case. But again, I'm ignorant. This is not my area. But the rates in, say, in England, in Europe, where they have, again, specific mechanisms for tracking these things, were on the order of, I think, on the order of tenfold higher than what was reported previously over the past 10 years in Brazil. So all of a sudden, there were numbers popping up, and they tend to be localized. So they tend to be in states that are in the Northeast. For example, one of the states, which is called Rio Grande of the North, or Rio Grande do Norte, they've, from the tables that I've seen that were put out by the health authorities in Brazil, they had, say, 35 confirmed cases out of over 100 that are being investigated. And some are being thrown out when they're examined in more detail. But if I went through the numbers, and assuming that these numbers are accurate, say 35 or 100, and assuming that the population numbers are accurate, and assuming that the birth rates are accurate, the numbers lie somewhere around the range of the upper limit of what's been reported in the United States at baseline, and up to maybe tenfold higher. So there is concern that there might be something going on. And clearly, one case too much is one case too much. It's a dreadful, horrible disease. But I think at this point, it's really not clear. The diagnosis of Zika, the frequency of microcephaly. I was just in Natal, which is a pretty big city. The state of Rio Grande do Norte is about 3 million people. It's a very poor area. And you could imagine that the population is much larger, or the birth rate is much larger than what's actually been reported. So a difference of threefold, fourfold, it's really hard to tell. Yeah, it could be.
And in any case, we're not dealing with something that's suddenly 100-fold higher than what we would expect, in the U.S., because the numbers were so depressed before that there's suspicion that maybe there was a lot of underreporting.
That's the impression one has, yeah.
I just don't understand why all of a sudden it started getting properly reported, right? Because there clearly has been an uptick since
right.
year.
This type of thing would once somebody starts the idea that there's an increase, that in itself will drastically increase reporting.
I mean, I think the bottom line is we don't know. I think there's a good chance that it's a reporting artifact, but if it's not, it would be a terrible thing to miss, and it has to be looked into.
Of course.
The other thing is even if there is an upburst of microcephaly, showing that it's related to Zika virus just because it arrived that same year is a whole other question. And you certainly wouldn't want to miss another cause if there really is an underlying cause that's different than Zika.
There are also some reports that I've seen now that the uptick in microcephaly may predate the arrival of Zika virus.
Really?
So we're not even certain that the timing is equivalent, or conversely, maybe we didn't see the beginning of the Zika virus arrive.
Yeah, we don't really know exactly when Zika virus arrived, only when it first came to everyone's attention.
Right. So there's a lot of missing data here.
Right. I was just going to say, today's New York Times had a story that kind of garbled the numbers, but going back to the original document in Portuguese, it wasn't written very clearly either. And I got Luisa, my Brazilian postdoc, to really look at it and summarize the numbers with respect to 4,783 cases of microcephaly have been reported. 76.6% are still under investigation. 1,113 have been finalized. So of those 1,100, 400 were confirmed as microcephaly, and 709 were discarded as not microcephaly. So there are starting to be some numbers in terms of how much false positive microcephaly there is in the
not microcephaly, or not microcephaly caused by Zika virus.
Just microcephaly.
Not microcephaly.
Not microcephaly. Didn't meet criteria for microcephaly, but was initially reported as such.
So even microcephaly is not a trivial thing to diagnose unless it's extremely severe.
Right.
And it has to go along with clinical symptoms. I mean, there's some variation in the size of the cranium.
I think that it's what makes it even more difficult is often it requires the baby being born, because depending on the severity of the microcephaly, you can't detect that in utero even by something like an ultrasound.
Right.
And so, and the other thing, of course, is that if it is the Zika virus that's being sort of associated, or the infection with Zika virus that's being associated with the microcephaly, it's complicated during pregnancy, because if the woman is infected in her first trimester and doesn't even realize she's been infected with something, but of course that virus has crossed and is now infecting the fetus, you wouldn't know that if you have a normal pregnancy, of course, until you deliver. The other complication, and this happens with a lot of the other torch pathogens, is although there can certainly be cases where there are symptoms at birth, for a lot of the torch pathogens, and again, a lot of this is linked to when in pregnancy the baby is, or the fetus is infected, is that there can be symptoms that manifest themselves years down the road that are all the direct result of being vertically transmitted in utero. So I think that's also something to keep in mind, is that I would be curious to see, now that they're paying more attention to these regions, whether other things kind of come about from this, if they're seeing, things that mirror some of the other torch pathogens in terms of symptoms.
Carolyn, do other viruses that cross the placenta cause microcephaly?
They can, and a lot of that doesn't seem to be their primary, the primary outcome of infection, but absolutely, a lot of them are linked with microcephaly in some form or fashion, and I think that's incompletely understood, but I suspect it's just a matter of when during development, when during pregnancy, the mother would become infected, and then the virus would.
And there are also environmental factors that can cause this that are not necessarily absent in an environment, in the environment where we're talking about.
Yeah.
What other? But these other viruses that sometimes cause microcephaly, they also cause other fetal damage.
That's
right?
exactly right. And some of them, I would say, and this is the case certainly for rubella and CMV, that they can be linked to microcephaly, but often the manifestations of those sort of congenital syndromes are far worse than just microcephaly.
Right.
Again, depending upon the stage of pregnancy when the infection occurred.
So this whole issue of diagnosing microcephaly, I mentioned, I think last week, that Gabriel Victora's dad, Cesar Victora, is down in Brazil. He's a doctor, and he has been one of the individuals who have established the criteria over the years for diagnosing microcephaly. And just this morning, Gabriel sent me a paper that just came online at the Lancet today, written by his dad. It's called Microcephaly in Brazil, How to Interpret Reported Numbers. And I don't know if it's open access or not, but put a link to it. And it really goes through the whole issue. What is the problem, all the different criteria that have been used over the years, and why the current criteria may not be the right one. For example, WHO says microcephaly is a head circumference below 2 standard deviations of sex-specific and gestational age curves. So you have to establish curves in the particular countries, I suppose, right? And that can vary from country to country. So this really summarizes the issues that we've been talking about. The other thing I want to bring to your attention before we continue talking, and I think this addresses some of the, or discusses some of the microcephaly. This is a letter from our TWiV fan down there, Esper Callis, who is a infectious disease physician. So let me read that to you. Dear TWiV hosts, writing from São Paulo, 23 Celsius, cloudy skies, humidity 100%, visibility 3 kilometers, wind 6.4 kilometers, east-northeast, no autochthonous Zika virus transmission in the city yet. So he's in São Paulo. As Vincent requested, I am writing an update on the Zika disease situation in Brazil. Most information is based on official reporting from the government. However, I will take the freedom to bring a few perceptions which listeners should take with a grain of salt. The most notorious information is how the media is covering the subject. Every front newspaper or weekly magazine portrays something related to Zika virus. It has been overwhelming and a good time to teach some virology to the general population. Needless to say, there are many conspiracy theories spreading in social media. Wackaloons saying that the virus causes neurologic defects in children up to 7 years old, and the microcephaly cases were caused by an expired vaccine. These are the front pages for the main 2 weekly magazines. An arthropod showcase in a picture I took at the newsstand 3 days ago.
I'd like to interrupt here and say that this the one that has the Zika as the big headline. So Zika, spelled Zika, has been a slang term or phrase used in Brazil for a long time. And so Louisa has told me that it's kind of a, you would just say, things were going bad. I got Zika, spelled Zika. I would love to help my friend to get out of this Zika. I now have a very difficult race. I think it will give Zika. Various things. So it's really kind of ironic. So that's where that headline on that magazine cover comes from.
All right. So then he has a microcephaly report, and he links to the government's release, which is in Portuguese. And he said the ministry, and I think this is what Kathy had referred to also, Ministry of Health issued another update on January 2nd with 3,670 suspected cases, 404 confirmed microcephaly cases. He says probably associated with Zika virus, and 706 discarded cases. Microcephaly has been detected in 22 out of 26 states. As per the map, Brazil has 5 regions.
He said January, but I think he means February.
February, sorry. Yes, I meant to put February in, but I forgot. Yeah, it can't be January. Most cases concentrate in the Northeast region, with 2,995 suspected cases, 401 confirmed. That's microcephaly. To date, 17 cases had positive PCR for Zika RNA. Personal communication, which is still a minority. 76 deaths attributed to microcephaly or other neurological defects at birth. Of those, 15 confirmed to be associated with Zika, 5 with identified Zika virus by RT-PCR, 56 are under investigation, and 5 were discarded. So let me pause there and ask Helen, so what do you know about RNA detection in amniotic fluid in these cases and in mothers? Do we have any reliable information?
Yeah, so we're starting to get more data about this. And so, the first association between Zika virus and microcephaly was the timing of it, that it showed up right after the Zika virus outbreak started. But now we have several lines of evidence, including the detection of Zika virus RNA in the amniotic fluid of 2 fetuses that were diagnosed with microcephaly. Zika virus RNA has also been detected in the tissues of infants who died shortly after birth who had microcephaly. And there's also been viral antigen detected in those tissues. Zika virus RNA has also been detected in the placenta of a fetus with microcephaly after miscarriage. And just recently, there was a report of Zika virus IgM in the CSF of infants with microcephaly. So there's accumulating evidence that Zika virus infection is happening. And, again, this doesn't establish a causal role necessarily or rule out other cofactors. But there does seem to be a growing body of evidence suggesting Zika virus infection in utero.
Right, which it's interesting if this virus can cross the placenta. It certainly puts it into a small club. But it's obviously important to get a denominator on that. How commonly does it cross the placenta? Because they're only looking at cases where there's microcephaly so far.
Right. And, this is also noteworthy for being totally unexpected for this group of viruses. I think we've already discussed how there certainly are other viruses that can cross the placenta. We've talked about CMV and rubella. Bunya viruses also are known to cause microcephaly in humans, and also there's a lot of examples in livestock as well. But no flaviviruses have previously been associated with this. So this would be a completely new effect for this group of viruses.
So what do we need in terms of studies to really know if there's a causation here with Zika and microcephaly or not?
I think the first thing is to get a better handle on the numbers. And that work is underway. There are groups working to gather better data about this. So I think we'll actually have a much better sense before much longer about how large of an effect are we talking about, and what is the risk. So if a woman's infected with Zika virus during her pregnancy, what is the probability of that infection being transmitted to the fetus?
So we need to know in people who are, people who give birth to normal babies, if they're also infected or not, right?
Right.
Because if you find Zika in everybody, that doesn't.
Then that's no big deal.
Right. Now the other issue that I have a problem with is all this is RT-PCR. You mentioned antigens. I didn't know that, but that could be who knows the accuracy or cross-reactivity or whatever, the specificity. I think it would be nice in at least initial cases to get some virus
Yes.
out of the amnion or the fetus or something like that.
Yeah, that's a lot more challenging.
It is, but I do think that a fragment of RNA doesn't really prove anything, because you can imagine it's replicating elsewhere. Maybe pieces of RNA are getting into the amnion, right?
But I think it's also important to keep in mind that if the infection occurred, let's say in the first trimester, which something that induces microcephaly, I would guess is probably much more first trimester, maybe early second trimester associated, just again, based upon just fetal development at that phase, you may not find and be able to isolate any infection virus because the infection is cleared. And I would say, and that's true for a lot of the other, sort of torch viruses, rubella, CMV, that, isolating infectious virus is quite difficult because, the infection is cleared by the time the baby is born.
Yeah.
And that's where this more recent report about Zika virus IgM in infants really becomes important. So IgG can cross the placenta, but IgM doesn't. So if you have an IgM response in an infant, that's a pretty good indicator that of an in utero infection where the fetus was mounting an immune response.
Right.
So the detection of IgM is an indication of infection.
And I would say that to me would be as profound of evidence as even starting to isolate the infectious virus. Just again, knowing the IgG is the only thing that crosses the placenta.
But it's also important to note that report, has it been peer reviewed, or is that?
No, this is just from a news story, which has been the difficulty with, gathering information as this outbreak progresses. Is we get a lot of reports about what's being found and in different studies, but there's really very little that's in the peer-reviewed literature at this point.
Right.
And also, you would like to know if, again, normal babies are making IgM against Zika, because that could be as well. I mean, is it
Probably
possible
not.
that you think that it's not likely that it's getting into every baby whose mother is infected?
I mean, probably not, but you'd have to rule it out.
Yeah.
Well, it may again depend on gestation. So it may be, rubella has a very finite window of when it can actually induce the worst disease. The same thing of VZV. So, VZV, if infection occurs, and the window for VZV is something like, 13 to 20 weeks of gestation. So it's a rather small window. And if the virus, if the mother becomes infected and exposed and it crosses into the fetal compartment, then, the damage to the fetus and to the baby is significant. But at other times it either does nothing or it does something else. And so this is the complexities, I think, of studying, vertical transmission of viruses. Is there's so many facets of this. When the mother becomes infected, that I think are going to have to be really closely monitored.
So and also the endpoint that we're monitoring right now, microcephaly, is very much a lagging indicator.
Absolutely.
So these are pregnancies that started 9 months ago or longer, and now we're noticing that there's microcephaly. What's going on right now? We don't know.
And it's possible, too, and this is data that would be almost impossible to actually get because we don't really even have it for the United States, is, first trimester early term losses, miscarriages, there's very little information and reporting on those kinds of things. And so, there could be, increases in miscarriages within the first trimester. And again, even in the United States, we have very flawed data on just the rates of those. Oftentimes, women don't even know they're pregnant. They don't report it. You certainly can't, isolate anything, tissue-wise from a first trimester loss. So that's possible too.
And especially if you had an infection that was so severe that it was causing that loss, that's never going to show up in these data.
Absolutely. Yeah, absolutely.
So, Carolyn, back when we had a lot of rubella in the U.S., were there, when there was an outbreak of disease, which happened periodically, was that then followed with increased numbers of fetal damage?
Yeah, absolutely. And I think that was what I think was observed was just huge increases in like congenital rubella syndrome.
Okay.
And that could really be linked often to when mothers, and again, part of that is symptom driven. So with viruses that are associated with more severe symptoms in mom, it's going to be a lot easier for those mothers to report, oh yes, I know when I became infected with this virus in my pregnancy because I remember, my symptoms. Zika, at least from what I've read, the symptoms seem to be relatively mild, certainly compared to maybe some something like dengue fever. And so these women may just have a rash or a fever and think nothing of it, and you don't, you don't really like make a mental note or jot down, I was this week, pregnant when I had these symptoms. But for rubella, the association even was quite dramatic.
Mm-hmm.
There was the outbreaks.
All right, so continuing with Esper's letter, he's talking about acute Zika cases now. It's very hard to say how the virus is spreading since the viremia is short-lasting and the access to RT-PCR is quite limited across the country. However, ID colleagues working in the Northeast region tell me that the number of suggestive acute rash diseases has dramatically decreased. On the other hand, the North and Central West regions seem to be having virus circulation at the moment. No case of local transmission has been documented in the city of São Paulo. My perception is that microcephaly cases is the developing of a picture of the epidemic taken several months before. Therefore, it would not be surprising to see declining number of acute Zika cases where one sees a surge of microcephaly cases. Tracking the virus transmission would be a more efficient way of implementing preventive interventions and counseling for women in reproductive age. And this reminds me to remind everybody that RT-PCR, you have to be really careful.
Yes.
If you got Zika virus around, you could contaminate your samples, right? Now, I'm not saying the Brazilians are doing that, but even here, as we all know,
Yes.
with the XMRV business, it was contamination. So to be really, really careful about this, and it would be tragic if... the point that someone brought up before is really important. If you focus only on Zika and it turns out to be wrong, maybe you've missed something else, and you don't want to do that.
Right.
Guillain,
In fact, I think when we talked about Zika last time, we brought up the fact that this was an area that had recently started trucking in truckloads of water that might have been, and you worry about, well, what's in the water?
Yeah.
Maybe this he's going on to Guillain-Barré, but maybe this is a good time to bring up the question. So, Zika has been in other parts of the world. It's infecting other countries other than Brazil, but we don't see it associated with microcephaly elsewhere. What do you think about that, Helen?
I think that's something that's really striking. So, we've alluded to this potential connection with Guillain-Barré syndrome, and we'll probably talk about that a little bit more. And in that case, we've seen several examples of places that had a Zika virus outbreak, and then there's a spike in Guillain-Barré cases. It happened in the South Pacific, in Brazil, and now in El Salvador and Colombia. That has not been the case with microcephaly. So far, the only cases of microcephaly associated with Zika virus have been in Brazil. Now, some of that might just be an effect of the numbers, that the largest number of cases have been in Brazil, so you have greater power to detect a rare event. This is also where the outbreak in Latin America started, and as we've discussed, this is a presentation that takes some months to show up. So, you'd expect to see a lag between when the virus arrived somewhere and when these presentations would start showing up. But it's certainly noticeable that there haven't been cases reported elsewhere. And, by now there's been a lot of Zika virus infections reported in Colombia and Venezuela, and we're not seeing a connection with microcephaly. So I think time will tell, and we need more data. But it's important to also start thinking about other potential contributions as well. So are there environmental factors, co-infections, or host genetic factors that might impact this as well?
I was just going to say that the thing I read about time will tell with respect to Colombia is that I think the first cases were reported there this fall, and it has the second highest number of cases, second to Brazil, but that it may still be too early, that all those first trimester pregnancies that started in the fall haven't, come to birth yet. So
exactly. And people are certainly looking for this. So I think if there is an association somewhere else, we'll know about it before much longer.
There's a nice article in the Washington Post about Colombia. I don't know is that on your list?
Yeah, I don't have the post, but I have an email here. I'm just going to divert to this email from Edward, who...
They say that in Colombia, from Bogota, there were 2,100 pregnant women who have had the virus, which is, you could imagine, is kind of at the edge of detection in terms of the numbers that in Brazil.
Right.
So it may just be too early.
Yeah. So Ed is from the University of Oxford, said they had a visiting speaker in their department, and that speaker pointed out the odd fact that the increase in reported microcephaly is much, much higher in Brazil than elsewhere, for example, in Colombia, which also has a high incidence of Zika, and much higher in a few specific regions of Brazil in a way which didn't correlate with virus incidence. When pressed on why this might be, he pointed out that responses to previous arbovirus outbreaks had led to very high pest insecticide use in some areas without the measures to protect humans that he would be comfortable with. At the time of writing, there's a correlation between Zika and microcephaly, but no mechanistic link. I would be interested in your thoughts. Could microcephaly be a result of intoxication by insecticides rather than arbovirus infection? Hopefully by the time you discuss this, there will be more data. Well, there aren't more data.
There aren't more data, but it could be.
Yeah. I mean, in fact, in December, we're talking about what you just mentioned, Alan, the water being trucked in, and maybe there was a problem with that. Who knows? Guillain-Barré. So this is back to Esper's letter. The Guillain-Barré cases continue to be observed, but no report is available with a consolidated number of cases in Brazil. Most seem to be mild, but few severe cases are noted. This perception has been confirmed in other countries. El Salvador just reported an increase in the number of GBS, and he gives a link to that. 46 cases, including 2 deaths from December 1st to January 6th. That's last year to this year, contrasting to the average yearly number of 169 cases. My clinical team is currently providing care to a 56-year-old woman with Zika-associated GBS. She came from a trip to one of the city capitals in the North region and developed a mild form of GBS after signs and symptoms suggestive of Zika disease. She had a positive Zika RNA by RT-PCR in urine in 2 consecutive days upon admission. Days 12 and 13 after onset of symptoms ran in 2 independent labs. Plasma samples days 12 and 13 were negative for Zika RNA. We are still monitoring virus shedding. After treatment with intravenous immune globulin, she is fully recovered and should be discharged tomorrow. Immunopathology for Zika-related GBS remains unknown. The role of a direct Zika effect versus the classical immune-mediated mechanism still needs to be investigated. And then he says, I will end here and let the TWiV team and the invited guests peer review this letter.
Where are the error bars?
Where are the error bars? But before last, please allow me to share some pictures I took in a nice library at a hotel in the mountains a few weeks ago. Between the books, some craft art pieces separated the books, made with clay by artisans from the Alagoas State, Northeast region. They portray what seems to be human figures resembling some of those very unfortunate babies born with microcephaly. These pieces were created long before the current Zika virus epidemic and may reflect how we may have been underestimating the problem of microcephaly in Brazil. Perhaps our folk artists have been having a better sense of the problems related to this condition than us. He sent some lovely photos here.
These are amazing.
I think we have a show image.
Yeah.
They do look like microcephalic kids, don't they?
Sure.
Yeah. Either this or the magazine headlines, or magazine covers. Yeah, it's a tough call. I have to link to both of them somehow. These are neat.
Yeah. So, Jeremy, do you know anything about Guillain-Barré?
Yeah.
Dr. Luban?
I saw quite a bit of it here at Columbia.
Yeah.
Columbia is a pretty major international referral center for neurologic diseases of all sorts. Mm-hmm. And I remember there were quite a number of cases that we would see getting referred, for example, to Louis Roland, who was the chairman of neurology. And often what would happen, someone would have a strange kind of weakness in their limbs, and they would get referred to him. They would come from all over the world. And he would set us on the patient trying to find occult tumors, usually. So it's very often seen as a kind of paraneoplastic syndrome. It's an autoimmune disease, and it's a disease where the immune system, which normally protects you from things outside your body, starts attacking the myelin in your peripheral nervous system. And the symptoms usually are associated with those peripheral nerves that are longest and therefore most sensitive to any changes in conduction velocity. So first, usually you have a bilateral limb, usually in your legs first, and then maybe your arms weakness. And it usually comes on over about 2 weeks, 3 weeks. And generally, most of the time it'll resolve, though it can take months and months, and it may not resolve completely. If it gets really severe, it can progress upwards and you can have trouble breathing. But it's associated with all kinds of diseases that create inflammatory states, and viral infections are one of them. It's been associated with, there have been rare cases of vaccines being associated with it, and those have been clarified and discarded. So the treatment, probably the most effective treatment, though I don't know how good the data are on this, is to filter the plasma. So you literally put someone's blood through a machine that filters all the liquid components. It's called plasmapheresis. Removes antibodies, probably, that are attacking the myelin sheath. And then you put the cells back in the person's vein. Much more commonly, if you don't have equipment like that, what's tried is a high-dose immunoglobulin shot. So you give non-specific immunoglobulin in high concentration, and maybe it just probably has something to do with Fc receptors on cells that are being recruited by the antibodies. And if you put in nonspecific antibodies, maybe you block the receptors and have less inflammation. That's a big hand-waving.
They don't treat with steroids at all, right?
Probably there are people who do that, and probably the people doing it are arguing every year, well, this year we should, next year we don't. And it's one of those things that goes up and down. I think there's been some recent basic mechanistic biology in the past few years about this Fc receptor business, though I don't recall specifically.
Helen, you know anything about that?
Not specifically, no.
And how about Zika and Guillain-Barré? How is that any? That's no more certain than the Zika microencephaly connection, right?
I think that because there are several examples of places that have seen a surge in Guillain-Barré cases following a Zika outbreak, the connection does seem to be stronger, although, I wouldn't say that we know for sure. I'm not sure that we have a great sense of the mechanism by which any infection causes Guillain-Barré syndrome. And we certainly don't know any more about Zika virus than we do for any of those, but a number of different infections cause, or at least have been linked to Guillain-Barré syndrome, and so it's certainly possible that
Guillain-Barré is a
could as
very
well.
difficult disease to diagnose. It's not like there's a test for it. It's in a sense, a complex clinical syndrome that you put together and you exclude all other possible causes. You're left with an association with a viral infection.
Yeah, that's the problem. There seem to be different triggers, so it's hard to nail it down to any one. And in some cases, you don't even know what the trigger was. I remember famously Albert Sabin, late in his life, developed Guillain-Barré. And I remember this is when I was contacted. I used to correspond with him, and he said he got paralyzed. And he said, now I finally know what it felt like to be paralyzed, because he worked on the polio vaccines his whole life. So that is Guillain-Barré. Let's move on to a few of these other letters. Now, you may know that last Sunday in the New York Times, our friend Michael Osterholm had an op-ed piece. And Anthony wrote us about this. The title was How Scared Should You Be About Zika? And
of course, being Osterholm, the answer is very, very scared.
Of course. A quote from the article. Some believe we need more scientific data to confirm these more severe manifestations. I don't agree. I believe the evidence is already compelling.
This from the man who told us that Ebola virus was going to become an aerosol-transmitted pathogen any moment now.
Yes, so take it with a large grain of salt. And Anthony had a nice comment. The main point of the essay, prevention through the elimination of vectors and the development of vaccines, of course, is very good. My concern is that effort without sound science will be a windmill tilt. I don't think it's right to conclude that he's convinced, because obviously from our discussion, we're not, and many other people aren't. And so what? I mean, I guess his point is he just wants to get resources devoted towards, mosquito control and
which is
looking
great
for emerging viruses.
Which is a great
It's
idea,
fine.
and has been a great idea for
Sure.
over a century.
But you don't need to couch it in saying I'm convinced.
He thinks he does.
That's
Yeah.
just wrong. So I actually tweeted, why does Osterholm have a pipeline to the Times when he's always wrong? First H5N1, then Ebola, now Zika. Well, he might not be wrong about Zika, but he shouldn't say that he's convinced.
So the I guess one issue that we haven't talked about is what the consequences of all of this fear could be. And if you think about it, if you were, I don't know, a young person living in northeastern Brazil and you were pregnant and you started seeing these images on television, it's absolutely terrifying.
Sure.
And the consequences to you, to your psychological state, to your family, to your unborn child who may or may not have anything related to this, it's quite a significant stress to put on a person that may not be justified.
That's exactly what bothers me the most about this, and at least even speaking from personal experience, is that I remember how terrifying pregnancy was. Truly, I mean, I remember from the moment I knew I was pregnant, sort of being aware of everything around me and what I was eating and what I was touching, and and again, that's what inspired me to work on the placenta. And so that's actually exactly what bothers me the most about this, is that, you're basically adding to the already tense and terrifying experience, which should actually be a wonderful experience of being pregnant, and instead you're sort of taking that away from people, and you're making them just terrified.
Well, and
it's
worse,
not just
potentially driving them to do things that are actually very bad ideas.
Absolutely.
And it's not just happening in Brazil. Already people here going to the clinics to see their midwives are getting, information about Zika. And I mean, information is fine, but if it promotes fear, it's not good.
Yeah.
Well, and there are policies that are coming out that are based on what I think we all agree is a real lack of data. And so I think many people will know that the CDC has travel recommendations that pregnant women or women planning to become pregnant not travel to areas where Zika is circulating. Now, that's basically all of Latin America and the Caribbean. And if there's a serious risk, then that's important information for people to know on it and to keep themselves and their families safe. But if there's not, I mean, this is a huge economic impact to those areas, and not to mention the personal impact to people who want to travel and maybe visit
family. And the CDC
family.
doesn't recommend against pregnant women traveling to France, which actually has the highest rates of toxoplasma of anywhere. And so, and that is actually directly linked to congenital infections. So, I mean.
Or how about pregnant women associating with young children who could give them CMV?
That's interesting. Yeah, I was teaching medical students this week, and Rachel Gordon, do you know her, Jeremy? She's an ID doc who runs the course, and she said, everybody's calling her and say, I'm pregnant, I want to go to the Caribbean for the winter. Should I go? What a tough call, right?
Exactly.
You just don't know. So you have to err on the side of caution, I presume.
So that's the CDC's take. As I understand it, the WHO has not advised any kind of travel warning.
No, they have not. That's correct.
No.
Which is an interesting contrast.
Yeah.
Right, and the CDC just yesterday or today came out with this thing that women who are pregnant or shouldn't have sex with their partners during the pregnancy because of the risk of sexual transmission of Zika virus.
Right. It's today. I put the link in the
Which
show notes.
I don't know what they're smoking down there in Atlanta, but that's just kind of silly.
Right.
So that is a potential mechanism, which I think we're going to hit on in a moment. But we're really reaching here.
Yeah. So
and the burden falls to the female and the pregnant woman, and that's again sort of. There's a lot of problems with that. I think basically this being the sole, it's up to the woman to protect the baby and not travel, and that's a lot. That's a lot of people to ask of people.
Well, and you see this in recommendations that we've heard from some countries saying, women shouldn't get pregnant, which is just not helpful from the get-go. But also, these are always framed as being women shouldn't get pregnant. No one is saying men shouldn't impregnate anybody until 2018, even though that has just as much rational basis.
Helen, can you review the evidence for sexual transmission of Zika?
Okay, I guess I volunteer.
Sure.
It'll take 10 seconds.
Let's go there because in my experience, that's what everybody wants to talk about. And so I think we can say that there is evidence that Zika virus has been sexually transmitted. There's now 2 cases where that seems to have occurred. One is a historic one, not related to this particular outbreak, but from someone who was infected with Zika virus in Africa and then transmitted it upon returning to the United States. And then just recently, there was an example in Texas where someone had traveled to an area with Zika, where Zika virus was circulating, became infected, and transmitted the virus upon returning to the United States. A third line of evidence is that infectious Zika virus has been detected in semen, although in that particular case, it wasn't known to have been transmitted to everybody.
Those first and third examples were what we talked about on TWiV 368 back in December.
Yeah, right.
So, I think significant role in the transmission of this virus or in starting new outbreaks. You just got cut off,
but what you said, it probably doesn't play a significant role in transmission, right? Sexual transmission.
I mean, this does happen. We have evidence that it does. I think we don't have any evidence that this is a significant part of the epidemiology of these outbreaks. Although, it should be said that I don't know how extensively this has been investigated. And so in the areas where there have been Zika virus outbreaks previously, there's lots of mosquito exposure. And so if someone's infected, you would presume that that's how they got it. So you could potentially miss examples of sexual transmission just because the mosquitoes are the simpler explanation of it. And I think as we have more imported cases into the United States, which is sure to happen, if this is a significant route of transmission,
people
that will
have
become apparent.
Been infected with mosquito-borne pathogens that have arrived on airplanes.
Sure,
that's certainly a possibility. Plane arrives, the doors open, the mosquito comes out and bites someone, and that's been documented.
Yeah, I think I personally am not convinced by the evidence of sexual transmission. I think the 2 cases we talked about last time aren't convincing. In this Texas case, we have no data from the CDC. We have to take their word for it, and I'm not actually willing to do that. So I agree that if it happens at all, it's pretty rare. So
I think the one actually that I find convincing is the one the researcher returning from Africa and giving it to his wife. That actually I think is pretty compelling because she had no other exposure to the mosquitoes in the area.
Well, maybe, but maybe he had it. Hey, maybe he was shedding.
He had sores on his lips.
Yeah.
And yes, the 4 children didn't get it, but
right. I mean, yes, you can.
I find this to be a reasonable explanation for what happened. You can never know for sure, but it seems to be the most
the point I was getting
likely
at was
explanation.
the other cases that are sure to come up where it's going to be pointed to as a sexual transmission. Most likely, it's going to be cases where both people had similar exposures otherwise.
I just think if you're going to tell people not to have sex, like Carolyn said, they don't do this for other diseases, and you should really be sure of sexual transmission first.
Yes.
Exactly.
Right. Let's move on to a couple of these other emails.
Before you do that, I just want to comment on your blog post today where you talk about making a distinction between sexually transmitted viruses like HIV versus sexually transmissible viruses.
Right.
And sexually transmissible viruses includes viruses that now and then might be sexually transmitted under certain circumstances, but which normally are transmitted by another route. I think that's a really nice distinction.
I think the headlines all said Zika is sexually transmitted, and everybody looks at it and they don't read the article and they go, "Oh my gosh, this is terrible." But an interesting last time we talked about Zika, I mentioned everybody's going to get all the antivirals and test them, and then you can then find some that inhibit Zika and use them in compassionate use. So Chris from the UK wrote. I wonder who these antivirals would be used in. there's the relationship between Zika and microcephaly is unclear. Even the demonstration of Zika sequences in brain tissue doesn't indicate that infection is causative. If it turns out to be an agent of microcephaly and antivirals are identified, are they going to be administered to women of childbearing age or women who are already pregnant? And he says we don't want to give drugs to pregnant people. And I would add that if it only causes symptomatic disease in 1 in 5 people, how would an antiviral be useful at all, right? So, yeah, I agree with that. That's true.
What about blood supply? Is that?
I presume it's checked for. Does anyone know in the blood supply?
It's not currently being checked for, but currently our blood supply is screened for West Nile virus, and once you have an FDA approved test for Zika virus, then you could screen in the same way. So right now, I believe the current recommendation in the U.S. and in other countries as well is a deferral, so that you wouldn't donate if you've traveled to an area where Zika virus is circulating.
And you're Brazilian?
And I would get.
And you're staying home.
I'm not sure how they're handling it there. I mean, so just recently there was an example of a case in Brazil that was believed to have been from a blood transfusion. And yeah, I don't know what they're.
Then the recipient is presumed to have been exposed already, maybe.
All right, we have a letter from your colleague, Helen, Steve Bockenheimer. I think you know him, right? So we talked about a Zika vaccine where you take the yellow fever vaccine, you put in the Zika glycoprotein, and he was worried about antibody-dependent enhancement. So maybe you could explain what his concern is and what your thoughts are about that.
Sure. So we've touched upon this idea of antibody-dependent enhancement already. I'll say that the fact that the yellow fever virus vaccine has been the backbone for existing dengue vaccine platforms and potential future ones for Zika virus, the fact that comes from yellow fever is neither here nor there. The antibody-dependent enhancement goes through the envelope protein, and that's swapped out for the vaccines. But it is a real concern because we know that between different dengue serotypes, antibodies to one serotype will still bind to another serotype of dengue, but they don't neutralize the infection. So they don't necessarily render that variant non-infectious. And in fact, not only are they not protective, they actually enhance the infection because they make it easier for the virus to infect its target cells that express Fc receptors. And it's certainly possible that a similar phenomenon could happen for Zika virus infection in a dengue immune host because we know that there's serologic cross-reactivity between these viruses. We don't yet have evidence, either in vitro or in vivo, of this happening, but there are systems that we can use to test this, and that's definitely something that we're looking into. But if you had a Zika vaccine, you wouldn't worry about, or maybe you would worry about enhancing dengue as well, the other way? Yeah. We don't know. So right now, because of how the outbreaks have occurred, the concern has been about Zika infection in a dengue immune host. We don't have any examples where dengue was introduced into a Zika immune population. But I would expect that in the years ahead, Zika will become endemic in Latin America, and then we'll start having examples where people are infected with Zika virus before they see dengue. And I would think that the concern would work in both directions.
Helen, let's say there's no association or no causation of Zika and microencephaly, would one still develop a vaccine for Zika? In that case, do you think?
Well, I certainly think a lot of the current push would be diminished without a possible connection with microcephaly. I do still think it's important to understand the interactions between this virus and dengue virus because of what we've just talked about in terms of the pathogenesis of the viruses, also potential interactions with vaccine development. There's large ongoing dengue vaccine trials happening in this area. And in order to interpret those results, you have to be able to understand how both dengue virus infection and also a dengue vaccine are interacting with this other circulating
So I got a couple of questions I want to make sure I'm clear on. The idea of antibody-dependent enhancement where, say, a dengue infection might enhance a Zika virus infection. That has not been proven to be the case, right? That's an idea.
Yeah, I'm not aware of anyone who has proven this yet, but we are certainly interested in testing
not
this
out
idea.
of the realm of possibility. And so in terms of vaccine development, I want to think a little bit more about sort of the Zika virus in an endemic situation. There's just one serotype, is that correct? And is there durable immunity to this? So if you get infected, are you immune down the road?
We don't know that, but that's probably
based on experience with other flaviviruses, that would make sense. So in a situation where the virus is endemic, is it reasonable? I'm thinking that a reasonable scenario would be that if there was a fair amount of the virus around, that most people would be infected and become immune well before reproductive age. Is that
That's probably true, and I think I see where you're going with this in terms of a possible connection with birth defects.
Well, if there were,
is that what you're thinking about?
If there is actually an association with birth defects, I can imagine a scenario where, in a naive population, when the virus first goes through, there's a big problem. Okay, but once the virus is established and you would get infected at a younger age, usually, okay, then by the time you got to reproductive age, you would have immunity and there would not be a problem. It's kind of like CMV.
Well, I think maybe even a better example for that would be rubella, as something that if you get as a childhood illness, you have lifelong immunity, no problem. But if you're infected during pregnancy, it's a big deal. And because of that, a rubella vaccine is very important. And so if it is the case that Zika virus does cause birth defects, and we've really only talked about microcephaly, but it's if the virus causes microcephaly, it probably causes other problems as well. And so if that's the case, certainly you might expect that most people would be infected as children and develop durable immunity, but you would probably still want to have a vaccination approach as well, much as you would for rubella.
That's an interesting point, Helen. You would expect other defects, but we haven't heard of them. Is that because the reporting is bad, or?
I think so. The microcephaly is something that's pretty apparent, although even in that case, the numbers are difficult, and more subtle defects might not be as obvious or just take longer to develop.
And I will add, that's very common with a lot of the torch pathogens. I mean, some of them, certainly how they manifest, the disease is quite apparent when the baby is born. But, toxo is a good example of you can be infected in utero with toxo and not be born with any outward symptoms, but develop them within, a few years of life. So it is possible that we will see that.
All right, Rich Condit, I'm glad you came online.
I've been here the whole time, like I said, sitting in the bilge listening to what's going on.
We have an email from our friend Scott in Costa Rica who tells us he thinks he got Zika because he had a rash and a fever, blah, blah, blah. But, and it's there. He wants to know, there's been something in the paranoia sphere for a while suggesting that GM mosquitoes released in this area in Brazil are responsible for the Zika outbreak. So I know Rich Condit's done a lot of research on this. Rich, in 10 seconds, what's this all about? I'm just kidding. What's this all about?
We actually shouldn't get too sidetracked with this. I did, because I got interested. I didn't really know much about these GM mosquitoes, so
they're very cool.
So they are very cool.
So what's the goal of this release?
The goal of the release is to squelch the mosquito population. So this was what's the name of the company? Oxitec. They have generated a line of transgenic mosquitoes that, with a tetracycline inducible operon in them, that in the absence of tetracycline, a hatched egg in the wild, in the absence of tetracycline, will express a protein which is actually just the repressor at fairly high levels that causes the problem, that will cause these mosquitoes to die at the larval pupal stage.
Right.
But in the presence of tetracycline, the expression of this protein is repressed so that you can raise these mosquitoes in the laboratory or in a culture facility in the presence of tetracycline. And so what they do is and there's this amazing video that shows this facility at work that it's really worth it. I watched this for 20 minutes. It's how you rear these mosquitoes, and how you separate the males from females. It's too complicated. I'm not going to go into it because it's really cool, but I'm not going to go into it. At any rate, you can raise in the presence of tetracycline and isolate hundreds of thousands on a production level of male mosquitoes that carry this transgene,
which also don't bite, right?
Right.
The males don't bite.
They don't bite. Release them into the wild. They will mate with wild female mosquitoes. These males are homozygous for this allele, so all of the offspring will be heterozygous, and that is sufficient
they'll
to
all
kill
die
them
at the
all.
larval phase. Yep.
They did a release near where, not in the same place, but near where the microcephaly is the reporting of the microcephaly is most pronounced.
Well, actually
a couple of years ago.
It turns out not to be as near as the paranoiosphere claims. They mixed up the names of which states this occurred in, and the release occurred a considerable distance from where the microcephaly was first reported.
And mosquitoes don't fly very far.
And mosquitoes don't fly very far, and these mosquitoes have absolutely nothing to do with anything related to transmitting anything to humans. And
So this is
actually the release of the mosquitoes caused like a 90% decrease in the mosquito population of that species in the area where the release happened. So it was quite effective. If you read the conspiracy theory that's linked in, maybe it was Scott's letter, it's totally wacko. It's talking about transmission of this transposon to Zika virus.
Yeah.
Blah, blah, blah. I mean,
idiots.
That is completely crazy. All right.
By the way, this strategy of releasing males that then produce sterile broods was originally developed back right after World War II by a fellow named Ed Nippling, was a colleague of my grandfather's, and was used. The version 1.0 of this was that you take your target species and you irradiate them. Mm-hmm. And you end up with that you sterilize the males by irradiating them, and then you release the sterile males in huge numbers. So this notion of having a huge facility where you raise large numbers of insects and then release sterilizing or sterile males all came out of that, and was used quite successfully in the United States to eliminate a major pest in the cattle industry called the screwworm fly.
Yeah, I think you've mentioned that before.
Been completely eradicated from the United States using exactly this type of technique. And now this Oxitec has taken that and brought it into the 21st century with this genetic engineering.
They don't want to get rid of all mosquitoes, do they?
I would love to get rid of all mosquitoes, but they want to... they're taking kind of the half measure approach of, well, we can release these males for a period of time and you can reduce the population in an area, and that's all well and good. Perhaps on some other episode we'll talk about gene drives. We went through one on TWiV not too long ago. They're really cool, and using CRISPRs, right? Which could be used. That's a technology that could be a true eradication, because it would actually spread the gene through the mosquito population and wipe them all out. But I don't want to discuss it more here. I'm not sure getting rid of all mosquitoes would be good.
Yeah, I wonder about that.
Dixon has an issue with that. Of course, maybe we could ignore Dixon, but
right. But how many species have humans wiped out already? By accident and by stupidity and by greed and by much, much worse motivations than this. And I think this is one where we really could do some great good.
In any case, there are two links that we have to blog posts debunking these things pretty thoroughly, so it would be worth putting in the debunking links.
Yes.
Just a few more emails. This one is from a science teacher in Oregon, Nina. She says it's balmy 49 degrees, and the balminess has got me thinking about mosquitoes. Usually our winters would kill mosquitoes, but I fear a mild winter is going to fuel the fire of mosquito outbreaks and potential chikungunya northward. I cover current events in my science classes. Lately, my zoology class and I have been discussing Zika, and they have brought up some interesting questions. What are the chances we will put together a vaccine or cure for Zika before the Olympics in Rio? What implications could the Olympics have for travel of this virus? Only 20% show symptoms, and it is long-lasting in the body. This seems like a recipe for disaster. The only hope I have is a story in the Wall Street Journal today citing a birth of twins where the mother had Zika and only one child had Zika. Could the drugs they give HIV-positive mothers to prevent the virus crossing placental barriers work for this virus? Thank you. All right. Who wants to stab? Helen?
Helen has.
You got some notes here?
Well, there are many groups right now working to develop a Zika vaccine. Pretty much anyone who has a dengue vaccine platform, which is a lot of different groups, are now using that approach for Zika virus. So it's certainly something that's being pursued. There's no way that something is going to be approved and in use before the Olympics. And in terms of the drugs given to HIV-positive women to prevent transmission, we would not expect those to be effective against Zika virus.
I should also mention, well, in the early part of the epidemic with HIV in, say, the 1980s, it was suspected that HIV could cross the placenta, and there were even descriptions of developmental abnormalities in kids. It became quite clear, and it's really quite clear now, that the infection of kids with HIV occurs at the time of birth. So the virus is not crossing the placenta. And the drugs that are given are anti-HIV drugs. They're not in any way blocking transmission across the placenta. They're just inhibiting HIV replication if it should get to the kid from the blood of the mother during delivery, which is when the transmission occurs.
It's very similar with hepatitis C virus as well.
Yeah.
Okay, Nina, tell your students that doesn't cross the placenta. It's very important.
HIV.
HIV does not, yes.
Zika, we don't know.
We don't know about Zika.
Does anyone know with the twins case of Zika, what kind of twins were they? Were they fraternal or identical twins?
I don't know anything about that.
I'm only because, in one case you'd have two placentas, in the other case you may have one placenta. I was just curious.
What's going to be really important is to get the numbers that we're talking about as soon as possible. For all the right reasons, and also because of this Olympics issue.
Yes.
I was interviewed by a Brazilian TV station here this week, and the guy, a 60-ish guy, he was complaining that the Olympics are going to be a disaster. And then he said, "Should I go to the Olympics?" And I said, "Why not? You're an old guy. You're not going to have a baby. What's your problem?"
What's his event?
No, he just wanted to go cover it, I think.
Oh.
One is from Michael, who is a first-year medical student hoping to specialize in infectious disease and tropical medicine. He's a fan of our show. Do it. He's personally connected to Latin America, and he's really interested in Zika. And so here, maybe, Jeremy, you can help. Like many first-year medical students, I have a few months off from studies this summer to do research. I figured there would be few better ways to introduce and possibly begin to establish myself in the field of infectious disease medicine than by trying to work with teams that are already investigating and trying to prevent the spread of this new infection. I am curious if you or any of your illustrious co-hosts have any suggestions about organizations that might be willing to take on medical students. All right, so this guy is in New Haven. I bet he's willing to travel. I would guess that Helen would be interested, or Carolyn, right?
Absolutely.
Sure thing. And I think there's groups in a lot of areas now that are working to understand Zika virus and have projects going on in Latin America right now. And I'm sure everyone's going to be looking for hands.
When I was a medical student, I had a block of elective time, and so it was the fourth year, so I already knew how to examine patients. I knew how to do basic lab work of relevance to HIV. This was 1985, 86. And I just wrote to HIV investigators that I looked up, I guess not on the internet at that point, in papers. And I wrote them letters on paper, which is another thing that's gone. and said, I can examine patients, I can do T-cell studies, and I'm interested in going to Africa. And I got a call from, in this case, it was Max Essex.
Oh.
And he sent me to Senegal, where I worked for a period of time.
Cool.
So, you've got valuable skills. So if you want, you can write to me. I can maybe help you find a specific person, but I think I can be contacted through TWiV somehow.
You don't have to send a letter on paper, in other words.
That's right. Anyway, you should just declare yourself, and someone will set you up, I'm sure.
One from Mike wants to know, presuming a link between Zika and microcephaly can be found in Brazil, do you think the reason other regions haven't reported this is that here more people have seroconverted before pregnancy? Helen.
Well, first of all, we don't know what's going on. I don't think that that's probably true, though. It's not the case that there's widespread immunity in other areas of the world. So it's possible that if there's an immune interaction, it has to do with Zika infection in a dengue immune host. We've talked about the phenomenon of antibody-dependent enhancement before as a way to see more severe disease. It's also worth noting that there's an Fc receptor on placental cells as well, and so that could be a potential mechanism for the virus to cross the placenta.
Okay, we have two more. Hang in there, guys. This is from Julia, who's an MD in Sweden. Here comes my questions about Zika virus, and I'll just read them. What is the evidence that Zika causes microcephaly? We've talked about that. Do they register microcephaly at the same manner as previously? Can better registration explain part of the rise? We've talked about that. We don't have an answer, but we've talked about it. What is the estimated risk of microcephaly in pregnant women in the endemic area? Pregnant women who become infected, diagnosed clinically by PCR or serologically. Is the risk lower if infection is without symptoms? Is the risk lower later in pregnancy? How soon can we detect microcephaly with obstetrical ultrasound? How long time does it need to develop? How does natural history of the fetal impairment look like? Does it progress over the time or reach any plateau, and when? Any other consequences for fetus children except microcephaly? How should we consult women for the future health intellect of these children? What are expectations about the development of the epidemia? Wow.
That's a lot.
Yeah.
That is a lot to cover, and it's pretty much a good rundown of all of the things we don't know and that we want to answer. I think the only one that we do know the answer to was when can microcephaly be detected in a fetal ultrasound, and it's usually around late second trimester would be sort of when that would first
But it also depends on the severity of the microcephaly, because there is a range. And so I think in very severe cases, that can definitely be detected by an ultrasound. But in less severe cases, that would not be detected at birth. And the other point to make is that I don't know routine ultrasounds, what their standard of care is in Brazil. Even in the United States, women often will only have throughout their pregnancy, assuming a normal pregnancy, 1 or 2 ultrasounds. Oftentimes that's the sort of ultrasound where you find out the sex of your baby. And so I don't know what kind of screening they even do in Brazil to know when that could be detected.
And it's worth noting that the routine ultrasound you would get midway through pregnancy here in the United States would be around 20 weeks, and that would usually be too early to detect microcephaly.
Any other thoughts, Jeremy? You're okay with saying we don't know?
Like it.
All right, one more letter. And this is from someone who's actually a listener, Aline, who is from Brazil. And so we'll read this. Aline writes, "Hi, TWiVziks. I'm really looking for
probably.
TWiVziks.
Yeah.
Zikas. Yeah, right. That's it. Yeah, TWiVziks. Maybe that's the lead in. I'm really looking forward to the next episode and very happy you're going to talk again about this big insidious threat, Zika virus. How could it be any different? A big concern for us from public health is the appropriate diagnosis. Even with dengue, a well-known disease with an improved diagnosis, there are potential problems to identify correctly. According to a letter published at Emerging Infectious Disease this month, here in Brazil, for every 20 dengue patients, only 1 is reported. If we imagine this scenario for Zika, usually oligosymptomatic with a difficult clinical diagnosis and test effective only during the initial infection, what can we expect? At least We have some good news today with the announcement by Brazilian authorities of a serological test from Euroimmune. Some Brazilian scientists are questioning the cross-reactivity with dengue. The CDC did not refer to this test at CDC's page testing algorithm. They have a page up there about this, and there also there's a link to Euroimmune. Regarding the explosive aspect of the epidemic, seems to me, in my opinion, it's just an opinion, that information about the vector and the virus have yet to be completely understood. At the following paper, no virus was isolated from any species of mosquito collected during the outbreak at Yap Island. Aedes Hensley was implicated as a probable vector, and that's what I pointed out earlier. But I believe we are on the right way. Brazilian people are very resilient and optimistic, and this weekend starts Carnival celebration. So at least until next Wednesday, the Zika sadness will be underestimated and Carnival happiness overestimated, and everything is going to be fine. At some point in the nearest future, everything is going to be real fine. Thanks a lot for sharing with everyone. So good information. Best regards, Aline.
Yeah, it could be a lot of alcohol and dancing might alleviate some of the fear.
Yes.
So, Helen, lots of tests are flooding the market, you think?
Absolutely. I think you can expect a lot of Zika virus tests to be coming
Yes.
out. I suspect most of these are actually just dengue tests, and I would really caution putting too much stake in them until their specificity has been verified. None of these are approved by CDC or FDA. I would expect, though, that good specific tests should soon start to become available because the reagents necessary to make such tests are already in development.
All right. Anybody else have any further comments before we move on? I think we covered everything that we could, right?
Yes.
Okay. This episode is also sponsored by the ASM Grant Writing Institute online webinar. This is a webinar that will help you write your grant proposals. It's for grad students, postdocs, and early career scientists. You'll get an overview of the grant writing enterprise, including writing NIH and NSF grants, and looking at a grant from the reviewer's perspective. It is a 6-part series taking place from March through June of 2016, and you need to apply. And this is the last time I will mention this because the deadline for applying is February 10th. You can go to bit.ly/ASMGWO16. The number is 16. bit.ly/ASMGWO16. We thank ASM for their support of TWiV. The last thing we need to do here is to make some picks of the week. And I will start with Alan Dove.
Okay, my pick this week is Jetstream, which is maintained by NOAA, the National Weather Service. This is an online weather school, and I know TWiV listeners will be very interested in this. For if you're into This Week in Virology and Meteorology, this is how you go hardcore on the meteorology part, and it's just a nice set of explanations of basic atmospheric processes and what determines the weather, and then tracks all the way down through different scales and what causes particular phenomena.
Great. So we can learn all about it.
You can learn all about the weather.
That's great. I see this one guy here is pretty funny. He's Professor Weather from Fort Worth, Texas. That's cool. Rich Condit, what do you have?
So I had an interaction this week with a fellow who calls himself the Mad Virologist and has both a Facebook page and a blog. He's actually, his name is Alma Laney, and he's a postdoc at Kansas State University who works on detection and characterization of luteoviruses in winter wheat. And he says on his about info on his blog that it's an effort page is part of an effort to flood social media with science and to engage the public in science-related issues. So he wants to, engage the public in real science. And he's one of the links that we had for debunking the mosquito, engineered mosquito conspiracy theory for the microcephaly. So, he's trying to do good with science, and I thought we had to give him a TWiV bunk. The blog and the Facebook page are pretty good.
Yep. I think more people need to do this, so that's great. I just would like him not to start every post with "so."
I don't know. I think that's kind of the way we talk.
Yeah, but you can talk that way, but to write it,
write that way.
Oh my goodness! Someone said we shouldn't do it so much on TWiV a long time ago. They said you guys use "so" all the time. Right. Yeah.
Many scientists do in speaking.
I know. Of course, it doesn't mean it's right, but
so you have a problem with that.
I think you're right, Kathy. Some people say "I mean" all the time, right? And they haven't said it.
They'll just start a sentence. Like,
I mean,
a lot of people say so.
It's like.
It's like.
Yes.
One of Alma's entries on his blog is really pretty cool. It's called Real Life Science because he has a field of wheat that he has to work with, and he went out to check his crops one time and found that a bunch of geese had destroyed half of his experiments. So this is things going wrong on a very different scale than I'm used to.
Yep. But things do go wrong.
Things do go wrong.
Kathy, what do you have?
I picked a short video of orcas in Antarctica. And so this is really cool because over on the left-hand side, there's a seal, and he's probably what's attracting these killer whales. But to see this many of them for this long of a time, and, it's so cool because their fins remind me of shark fins, and it's just amazing to watch. My older brother sent me this because, of course, he's got all kinds of connections to Antarctica, so I thought I would pick this.
Yeah, it's pretty cool.
I thought that seal was going to be toast.
Yeah.
But he did okay, at least as far as the video is concerned.
Yep.
I'm sure you've seen those videos of great whites ripping seals out of the water, right? Yep. Poor guys. Nature is cruel.
Nature is cruel.
Jeremy, what do you have?
Actually, I have two. The first, I wanted to recommend that people watch all the films by one of my favorite Italian film directors, Vittorio De Zika.
What brings that up?
Just that I thought it might be a reasonable pun.
So what is one... Oh, I see. The Zika. So you're not really recommending that, is it?
I am recommending his movies, but it's irrelevant for this.
What is your
podcast.
favorite De Zika movie?
I don't know. I like the Garden of the Finzi-Cantini.
Yeah.
I don't know. It's hard to pick a specific one as the favorite.
Jeremy, I should say, is into things Italian because he married an Italian, right?
That's right.
That's probably the sole reason. Vittorio Di... Otherwise, you wouldn't pay any... I'm looking him up now to see
I've got it. I'm going to put the link in for you.
I just want
There's
to see...
also a link to your friend, what's his name? Gabriele Vittoro. It's getting too far removed here. Anyway, my actual pick was a TED Talk by Pardis Sabetti, who's a researcher up somewhere in Boston. It's a very inspiring talk, TED Talk about her lab's efforts to study Lassa fever virus in West Africa, and then how that led into efforts with Ebola. And it has a lot of nice messages about music as well as research, and about working together with people around the planet. And they're really establishing kind of a new paradigm for how people around the planet can work together to solve problems. And I think there's perhaps a lot of lessons there that might be useful for the problem in Brazil today.
It sure is.
Cool.
Vittorio De Zika directed The Bicycle Thief, which is wonderful. I was just looking up to make sure he was the director. Did you see that one, Jeremy?
Yeah.
It's awesome. It's a very sad movie, but very awesome. And I love that one. Helen, what do you have for us?
Well, Valentine's Day is coming up, so I thought I'd pass along some suggestions for some science-related Valentines that listeners can cut out and pass along to that special someone in the bay next to them.
Nice. They're not virus-related, are they?
I did not find any virus-related ones, but if anyone has seen any, I would love to know about them.
Yeah, I'm sure there are out there. Maybe our listeners will now send us some.
Oh, please do.
These are funny. These are very funny.
I like this. Roses reflect a light frequency at one end of the visible spectrum. Violets reflect a light frequency at the other end of the visible electromagnetic spectrum. Sugar is C12H22O11, and you release endorphins in my brain. Really? Pretty good.
Oh, some of these
Who wouldn't be won over by that?
Right.
they have this one I like. Our bond is so strong.
So strong, I think it's covalent. Yes.
Bond, covalent bond. Yeah, that's pretty cool. Hey, Carolyn, do you want to have a pick?
Sure. I would say two. One is probably no one's going to want to pick, which is I have been buried this week reading an obstetrics textbook, which I would which I would recommend to everyone to learn about, again, placenta, torch infections. But I guess my real pick is I've been really enjoying a lot of the dialogue, especially this has been on Twitter, about these warnings that have been released about pregnant women and not getting pregnant. And there's a really good one today that was actually tweeted by a postdoc in my department that is on something called damemagazine.com. And the title of it is the 3-letter word missing from the Zika virus warnings. And that 3-letter word is men. And so it's actually a really nice post about sort of what we kind of touched on a little bit before earlier, where that the women are kind of having to, take the brunt of these warnings. So I would definitely recommend reading that post. I enjoyed it.
Cool.
Well, you have to feel bad for men. They miss out on having kids.
Oh, yeah. I feel very bad for men.
There was just a study saying that two genes on the Y chromosome are sufficient to substitute for the whole Y chromosome.
Thanks.
2 genes, huh?
Yeah.
That's it. All right. My pick is some new art by Michelle Banks. I picked her website on Etsy, Ortologica, a long time ago. And this week she released 2 new black and white watercolors of viruses, of course. They're both originals, and they both have 6 panels with different viruses on them. She usually does watercolor, but this one is all black and white with a little tinge of color. Really beautiful. They're unique, one each only. And you should check
one
them
of
out.
them includes adenovirus, which she didn't have in her repertoire till I commissioned her to do one for me.
Yeah. Yeah. So I commissioned her to make a logo for Microbe TV. She's working on it with
nice.
with the Vexed Muddler. They're collaborating. Isn't that cool? 2 science artists I got together. We'll see how much that costs me. But anyway, these two watercolors are beautiful.
Mm-hmm.
And
Yes.
they're $75 and $150, but you put them on the wall, you frame them, and they'd be there forever. And so they're really nice.
These are cool.
She does great stuff. We have a listener pick from Eric, who writes, "Hello, TWiV crew. Like Alan in the last episode, I've received my Go Viral kit, and strangely, I must say, this is the most eager I've ever been to actually get ill. Nobody enjoys getting the cold or flu, but the promise of getting sequencing data back makes it most desirable and interesting to this fellow virologist. Mainly, I'm writing to suggest a listener pick of the week. Back in November, my sister got me hooked on crossword puzzles. Whenever I got stuck on a difficult question, I would lament, arg, arg. I wish they made a crossword puzzle for microbiologists. A couple of months later for Christmas, she bought me a copy of Crossword Puzzles for the Microbiology Savvy by Dana Perkins. Puzzles are challenging but fun even for someone who is trained in microbiology. Hope all is well. Regards, Eric. That's cool.
Yeah.
One year at ASV, Ann Palmenberg released a virus crossword puzzle. And I have it. I'm actually going to ask her if we can post it because it's really cool. And if you're a virologist, you can get them all. Maybe that should be no, that's no good. That's not a good contest to win a textbook because that's too easy, right? You can just look it up. All right, this All Zika episode is going to be at iTunes and microbe.tv/TWiV. And if you have more questions that we can't answer, we're happy to...
Because there's no data yet.
We're happy to try. Yeah, there will be data, I'm sure.
Yeah.
So what do you think, Helen? In about 6 months, there'll be a flood of papers?
Absolutely. There's a lot of groups working on this right now, so I expect probably just about when the media attention is dying down, that's when we'll start to have real
So
answers.
all these results are really gestating right now.
Right.
I'd say so. They'll be, we'll be ready to birth them soon enough.
Well, both you and Carolyn are working on this, so we'll look forward to your papers and talking about them here on TWiV. But anyway, you can send your questions and comments to TWiV@microbe.tv. And I want to thank everyone for joining today in this All Zika episode. You know, we didn't hit the record because Dixon didn't want to come in. He's got a cold and he's coughing a lot. So 7 is the max we've ever had on TWiV, and that's what we hit today. Helen Lazear at University of North Carolina, Chapel Hill. Thank you, Helen.
It's been great.
Your colleague was up here this week, Stanley Lemon.
Oh, terrific.
And you may know someone from the Diamond Lab. I forgot her name, but she's from Australia.
Jenny
She's coming
Hyde.
up here to visit also in a couple of weeks.
Oh, terrific.
So we have a flood of virologists coming by. It's wonderful. Anyway, thank you so much for joining us. We appreciate it. Carolyn Coyne is at the University of Pittsburgh. Did the snow melt there, Carolyn?
It's a beautiful day. Basically, the day after you left, it became really great weather.
Thank you, Carolyn, for joining us.
You're welcome.
Jeremy Luban is at the University of Massachusetts in Worcester. Thank you, Jeremy.
Thank you, Vincent.
You had some good clinical insight. Maybe we should have you on now and then to provide clinical insight.
Or, yes, or more confusion. But I'm happy to be here.
Kathy Spindler is at the University of Michigan in Ann Arbor. Thank you, Kathy.
Thanks. This was a lot of fun. It was fun to have everybody on.
Yeah, it's always cool. Rich Condit is at the University of Florida. No, he's not. Rich Condit's an emeritus professor at the University of Florida in Gainesville. Thank you, Rich.
Sure thing. I'll use Kathy's line. I learned a lot.
You got to have your own line.
Yeah, well, my line is sure thing, always a good time.
Right.
Okay? But I did learn a lot. So I'm stealing Kathy's.
I think we all did. Alan Dove is at turbidplaque.com. You can also find him on Twitter. Thank you, Alan.
Thank you. It's always a pleasure, and I also learned a lot.
I'm Vincent Racaniello. You can find me at virology.ws. You've been listening to This Week in Virology. Thanks for joining us. We'll be back next week. Another TWiV is viral.